First of all, thanks for this invitation, Sascha. I'm going to talk about extension in the South Central and Patagonian Andes, from the Jurassic to the Neogene. Just a description of the main phases that affect the retroar zone. The main objectives of this short talk are to show you that background extension has been as important as orogenic construction through Andean evolution in time. And also that background extension does not correspond to a single mechanism. The first extensional unit in the South Central Andes is composed of rhyolites of late Triassic age, middle Triassic age, which correspond to the Choy group. The Choy group is basically a large igneous province in the Andes, in the retroar zone of the Andes, and they constitute a continuous blanket through the retroar zone. We are going to talk to call it the first extensional unit. And after this, there appear a second extensional unit, which is early Jurassic in age, and constitutes a series of isolated deposenters. All of them are early Jurassic, 200 to 195 approximately, and they are following the main discontinuities that have amalgamated the basement of the Andes. So they are interpreted as extensional activations of the main shooters. In seismic lines, you can see at them, they have an orientation which is west, northwest, or mostly east to west, and those are perpendicular to the main Andean strike. And in the orogenic front, you can see the main Andean structures that expose those structures. And you can see here the extensional structures and the seam reef filling, which are dacitic domes and rhyolitic sequences. And the orientation of the main structures is similar to the one that we saw in the seismic line. So it seems that there is an extension which is parallel, more or less parallel to the main Andean strike. And in the middle Jurassic, the pattern changes drastically, and we see continuous blankets of sedimentation, which are Pacific derived, and those are limestone and sandstones of middle Jurassic age, without an extensional control. And again, in the late Jurassic, again, we have an extensional control in the retroar zone. And in this case, this is the Tordillo formation, which is late Jurassic in age. And you can see the extensional folds, which are controlling the main packages of this unit. And the orientation of the main deposenters changes. Those are definitely northwest, and the extensional axis changes to northeast. This extensional episode reaches the early Jurassic. This is the Vaca Muerta formation, our most important hydrocarbon sequence in the Southern Andes. And the base of this unit is controlled by extensional deformation. So the change in the main orientation of the early Jurassic to late Jurassic deposenters in the Southern Andes could be explained by the absolute movement of Pangea and then West Gondwana during the Jurassic. Basically, Pangea moves parallelly to the subduction zone during the early Jurassic, and this movement changes in the late Jurassic to a movement which is directed to the northeast, to the northeast. So the main direction of the extensional deposenters could be explained by this change in the absolute movement. After this, the South Atlantic Ocean started to open, and South America started to drive to the west, and this time is associated with the first contractional episode that affected the Andes, which is late early Cretaceous to late Cretaceous in age. And all the deposenters that we have described are inverted during this time. And again, after the formation of the first late Cretaceous orogenic Proto-Andes, the axial zone of this orogen is reactivated in the intra-arc and retroarc zones, and a series of volcanic rocks, which are late Cretaceous in age, 80 to 70 approximately, are controlled by extensional deformation. So the first late contractional episode is affected by extensional tectonics. This extension is younger to the Patagonian region. You can see a wedge-like depositors in this case, which is late Paleocene in age. All the units in the retrovar zone are controlled by extensional deformation and are forming depositors, isolated depositors, which are younger to the ones that are described to the north. So one plausible explanation for this diachronism through the Andes in the late Cretaceous to the Paleocene could be related to the subduction of the Aluk-Farellon mid-ocean ridge that was subducted next to the northern Chilean origin at 80, which is the age of the extensional depositors in the north. And this triple junction migrated to the south towards Patagonia and interacted with northern Patagonia in the Paleocene, which is the age of the depositors in the south. After this second Scene Andean extensional episode, the Andes are again reactivated contractionally in the late Eocene. This is the second contractional episode that affected the Andes. And again, during the Oligocene, the Andes are extensionally reactivated in a second Scene extensional unit and Scene Andean extensional unit, which is controlling the main packages of volcanism in the Altiplano towards the axial Andean zone, towards the south in the Andes of Santiago de Chile. And this extensional episode, which is late Oligocene in age, reaches the Pacific coast. You can see here the thoracic basement, which is affected by normal faults and controlling a beautiful wedge-like deposit, which is Oligocene in age. And when we move again to Patagonia, in the archipelago de los Chonos, there is a series of islands here, which are composed of late Oligocene sedimentation and volcanism, which correspond to the Traiguén Basin. And the Traiguén Basin is very different to the basins to the north. In this case, there are pillow lavas, which are covered by turbidite deposits. And these pillow lavas and breccias are fed by dikes. So it seems that we have in this case the upper section of a mid-ocean ridge or something which is next to it, that the archipelago de los Chonos created some kind of oceanic crust during the late Oligocene. The gravimetric data shows a stripe of positive values of the gravity data, which is showing the position of the oceanic stripe in the fjords west to the archipelago de los Chonos. And in the northern part of it, Hervé had described in the last years a stripe of mantle materials, peridotitic materials, which are associated with this spreading center in the retrovar zone. I'm going to jump this, and which could be the explanation of this late Oligocene extensional deformation. This is the time when South America, the absolute movement of South America decreased, and exactly at the time of the formation of all these basins. The Abanico basins in the north, the Altiplano basins, and also the Traiguén Basin in Patagonia. And also the numerical models have predicted that during this time, the rollback velocity would be maximum and then decreased during the Miocene. So it seems that we have a combination during the late Oligocene with a very low velocity of the continent against the trench and a rapid rollback velocity. Again, after the late Oligocene, all these basins are inverted in the late Miocene contractional phase of the Andes. In the Quaternary, we have a series of extensional depositors also in the retrovar zone from the Pliocene to Quaternary, but the origin of these isolated depositors, such as the Loncopué Trough in the Neuquén Andes, seems to be associated with local changes in the geometry of the subductive slab. For example, the Loncopué Trough is associated with the tearing that is affecting the subduction slab. So, as a conclusion, we have several phases of Andean retroarc extension in the Andes. Some of them are pre-Andean, and 3 of them are Sin-Andean extensional phases. And the time, which is interesting, is that the Sin-Andean extension comprises approximately 35 million years, which is in the order of magnitude of the time that is comprised by contractional deformation. If we zoom the pre-Andean phases and the Sin-Andean extensional phases, we have almost 100 million years, which is at least 2 times the time of growing, of contractional deformation. And finally, the mechanisms which are associated with this, with each extensional phase, are very different. The oldest could be related to a lip, a large igneous province. The early Jurassic volcanism could be because of its orientation, intraplate extension, and chemistry. The late Jurassic and early Cretaceous phases could be related to proper retroarc extension. The late Cretaceous orogenic relaxation of the orogen could be related to an asthenospheric window, the subduction of mid-ocean ridge at that time. The late Oligocene phase could be related to accelerated rollback and continent slowdown. And finally, the Pliocene to Quaternary deposenters could be related to small variations, changes in the geometry of the subductive slab. So retroarc extensional triggers seem to be very different, and there is no single pattern and mechanism through time. And that's all. Thank you very much.
Thank you, Andrés. Are there any questions? If so, please type them in the chat. And I would have one to start things off. The results that Valentina showed before with this mantle exhumation, are there any exhumed mantle rocks that you can compare to? Did this happen in the Andes? And what can you say about how much they are representative for other settings, for instance, for the Mediterranean?
Yeah, definitely. In the late Oligocene, Pancho Hervé has described these peridotite rocks, which are assigned to mantle rocks, which are late Oligocene in age. So this could be related to the late Oligocene phase of extension in Patagonia. But there are other examples for older extensional episodes that could be related also to extensional phases. They have been usually assigned to contractional accretional processes, but I think they could be revised to see whether they could be associated with extensional phases.
Okay, thank you. There are no more questions in the chat, but I see that Gianreto, you have a question.
My question is about the Colorado and the Salado Basin, for instance. How are they related to this history? Because if you're looking the opening of the southernmost part of the South Atlantic, there are extensional systems. Are they related to this subduction system?
Sorry, I didn't understand which basin are you talking about?
Do you know if you take the Colorado Basin or the Salado Basin?
Colorado Basin. Yeah. Colorado and Salado.
How are they fitting into this history? Because they are quite far away from the subduction.
Yeah, exactly. Those basins are perpendicular to the main Andean strike, and they have been associated to Aulacogen mechanism. So these are perpendicular to the South Atlantic margin. Mm-hmm. So they could be part from of a triple junction geometry. Yeah. So this could be Aulacogens to the Pacific margin. They could have nothing to do with the Andean processes.
Okay, thank you.